Welcome to Stennis Space Center. Today we're going to be testing a RS-25 rocket engine behind me in just a matter of minutes. I'm here to give you a short commentary on what's about to come. You'll be seeing a very large steam cloud generated, much different than what you would notice in a launch. Normally in a launch, the vehicle takes off and disappears within a matter of seconds. Very difficult to see in just a short time, but what you'll see today is 420 seconds of hot fire time on an RS-25 engine, generating a large amount of steam and potentially rain from the plume of the rocket. We have a group of engineers that have been working behind me for weeks, actually, for this test. And in this day, they've been diligently preparing the engine and the systems that feed propellants to the engine for this test. Right now, they're pressurizing the two large tanks on top of the test stand to parameters that will test the limits of the highest pressure we expect to see during a start, during a vehicle flight. And we demonstrate many parameters like that here at Stennis through robust systems, through like this test stand behind me, which simulates a flight vehicle in a much more robust way, where we can operate the system over and over again and at an efficient cost. So we have a single engine that's going to be firing in this test stand behind me on the SLS program. When the vehicle does launch in the future, it will have 4 of these engines installed in the aft, along with solid rocket boosters on either side. So it'll be a much higher thrust level, but the view you'll get here today is very close to the operation, much closer than you'll probably get an opportunity to be to a rocket engine anywhere else. So I hope you enjoy that. As they're moving forward into the test preparation, they're verifying all of the pressures, temperatures, strain measurements, making sure everything's within parameters and ready to go for the test. They're going through a very high-stress countdown into the point where they will literally punch a button to start the engine. And after that, it'll be controlled by an engine controller and other computers that are checking the health of the engine as it runs and giving it its commands through different power levels. Today, you'll be seeing this rocket engine run at up to 111% of its design load from its original design. There'll be a great bit of 109% power level. One short duration of 4 seconds at 111, and then excursions. There'll be several, up to about 14 to 15 excursions between different power levels in the engine. So you may be able to notice that in the plume, as you'll see more energy and less energy emitting from the thrust bucket that will be emitting out to your left as you view it. So we hope you have a good viewing today, and everybody here gets to enjoy the humidity while you on NASA TV get to sit in your air conditioner and watch this wonderful show. We may get rained on by a rocket engine, however, here locally. You need more? Okay. 1 minute siren, so we're getting really close, and hang on for a show. For those of y'all here, it would be a good time to put your earplugs in. And maybe about the west, fair path.
fine. Just start me off, you know, see what we see today. Look at the camera or look at her? Got it.
Kim, it was great to see the mighty RS-25 roar to life today. So with the low cloud cover, the high power level, we really made the ground shake and shirts rattle. It's a great day to be a part of NASA's SLS program on this step towards our journey to Mars.
Was it a successful test?
It was a very successful test. We ran our full planned duration of 420 seconds. We didn't have any failure flags pop up in the controller, and it looks like we achieved all of our data objectives with this test.
And what's next?
What's next is the next test series starting this fall, where we will take another step towards certification for flight on the SLS rocket. Thank you.